Okay, so we have a question right here. It basically says that a teacher demonstrated the principle of conservation of linear momentum using two gliders A and B and an air track. A has the same mass as B. A and B were initially stationary and then A pushed gently towards B as shown. State the principle of conservation of linear momentum. So basically what does the principle say? It says that the total momentum before the collision must be equal to the total momentum after the collision. Either it must be in a closed system or there must be no external force. So basically you can write it another sentence. There must be no external force, or you could say it must be in a closed system, or it must be in a closed system. They basically mean the same thing. There must be no external force or there must be in a closed system, right? So this is your final answer. Okay, so part B says that a magnet was attached to each glider. The glider collided and stuck together, right? A data logger and sensor were used to record the velocity of A. The velocity recorded after the collision was half the velocity recorded before the collision, right? So basically that's still talking about velocity A, right? Deduce whether these results show the law of conservation of linear momentum, that the law of conservation of linear momentum is obeyed. Okay, so let me explain you using the formula of law of conservation of linear momentum, which is m1 u1 plus m2 u2 is equals to, now it won't be m1 v1 plus m2 v2, it will be m3 v3. Let me explain you what are these basically. Yeah, so m1 and m2 are basically masses of glider A and B, and u1 u2 are basically the initial velocity of glider A and B, initial velocity, right? And basically m3 is the combined mass, right, of A and B, and v3 is basically the final velocity of basically combined A and B, right? Final velocity of combined A and B, right? And velocity. Okay, so now let me explain you through values. It's much easier to understand through values, right? So basically let's say that each glider is 10 kg, right? 10 kg, 10 kg, right? Initial velocity of basically a glider is, let's say, 5 meter per second, right? And as you know that the initial velocity of B was basically 0, it was stated above here, right? A and B were initially 0 and then A was pushed tangentially towards B glider B, right? So basically here A is only moving, right? So now once you multiply 10 with 5, it becomes 50, and then 10 with 0 is 0. When you add them up, their final answer is 50, right? So now let's do the right side, which is basically after the collision, right? So the mass of basically both gliders is actually 10 plus 10, which is 20, right? Now what about the final velocity, right? So basically says that the velocity recorded after the collision was half the velocity recorded before the collision, right? So basically they're talking about the velocity A, how velocity A had basically the 5 before the before the collision, and after the collision it became 2.5, right? Half of 5, right? Which is basically dividing it by 2. So once you basically multiply 20 with 2.5, it becomes 50. Now as you can see that they are both equal, right? So only this thing we have to explain in words for this particular question, right? So let me write the basically the word form for this question, right? Okay, so basically we have to mention that what is momentum. You can write the formula for this, or either you just say that momentum is mass times velocity, right? And basically mention this statement right here properly, right? Why is this basically affecting the after the collision stuff? So basically, and the colliders got collided, causing the mass value to be doubled, right? Due to the velocity being halved, halved due to the velocity being half of its original value, basically after the collision, right? The momentum basically remains, you can say same or constant, same. So the law is obeyed, right? So basically this is your final answer. Okay, so part 2 says that explain why the force of attraction between the two magnets did not affect this demonstration, right? So basically let's say this is glider A, right, with magnet here, and glider B here with magnet here. Okay, so basically what happens is that glider A magnet will pull glider B towards itself, right here, and glider B magnet will pull glider A towards itself. Okay, so basically they will start moving towards each other, and of course as per the previous part it will collide, right? So basically we have to explain why these magnets are like working as an internal and not external forces, right? So basically the magnet provides like a magnetic force, right? So basically these magnetic force for the both of the gliders are actually equal, you know and in opposite direction means that they are pulling each other, like glider B is being pulled by glider A and glider A is being pulled by glider B. That's what meant by an opposite direction. So basically we have to explain all of this in a word form or a simple sentence. So let me write that sentence for you guys. So basically we will say that the magnetic force between the gliders, right, are equal in size and opposite in directions, right? Opposite in directions. One way to understand more is that, for example, this magnet is north and this magnet is south, so basically north and south pull each other. So this one way you can understand this. That's what is meant by an opposite direction or an equal in size, right? So basically this cause one glider to speed up while one glider to slow down by the same amount. So this statement might be confusing, that okay, why the one of the glider is speeding up and the other one is slowing down? Shouldn't they both speed up? Basically this sentence says that thing, but in a different way. Let me explain you. Basically your glider A, for example, this is your positive direction, right? Motion of direction, right? So basically your glider A is going here because the glider's B magnet is pulling glider A here, and glider B is going here because of the glider A magnet is pulling it over towards the left side. Okay, so glider A will have a positive momentum, right? It will have a positive momentum, while glider B will have a negative momentum, right? Because it has negative velocity, right? Because the negative basically means the direction, right? So your positive motion of direction is towards the right side, so your velocity value will be positive towards right but will be negative towards left, right? So basically this is what the sentence is saying and nothing else, right? So now we just have to add the final line here, which says that since these forces are internal and there is no external force acting on the system, right? They, let me write it here, do not affect the demonstration of momentum conservation. Okay, so I hope this is clear. If you have any questions, you can drop it in the comments below.